Okay, in this video we're going to be talking about analyzing graphs of functions. This is section 1.5. Let's talk about our objectives from this lesson. The first objective is we're going to be talking about how we find the domain and how we find the range of a function. We're going to talk about how we utilize the vertical line test to determine if a function is a function or if a relation is a function. We're going to talk about finding the zeros of a function and what that means. And then we're going to determine increasing, decreasing, or constant intervals within a function. Okay, before we dive into this, let's just do a little bit of inequality review from the number line and kind of talk about what interval notation is. If this is my number line, we learned in algebra class that if I have an inequality, colored in circle, that indicates that we're going to include that particular number, and if I have an open circle, I do not include. So that's an important piece of information here. Now, in this particular inequality, if we're going from left to right here, we know that we're starting at -2, and if we do our variable in the middle here with an inequality, we're saying that x is going to be greater than or equal to, it's equal because we're including it with the colored in circle. And as I go across here, this is all shaded in until I get to 4. So I'm going to go less than 4. Okay, so that would be our inequality, the way we would write that. Now, how do we write that in interval notation? So interval notation, the colored in dot, or the numbers we include, we use brackets, so that means to include. And then parentheses means we do not include. So in this particular problem, if we were to write this in interval notation, -2, we are including that, so we would say this is a bracket, -2, comma, and then we're going all the way across to 4. Well, we're not including 4, so that's why we are going to then use a bracket. And then again, this is called interval notation right here. And this is the way that we're going to describe intervals within our functions. Okay, so let's go ahead and go on to our next item here, and let me go ahead and erase what we did there with the last slide. Okay, so here's what we've got. We've got a function here, and we're going to just talk for a minute about domain and range. And let's just review from our last little video that I did. Remember, domain is our inputs, again, our x values. Our range is our outputs or our y values. Again, if I'm describing the domain of the graph, the domain is all of our x values. So if I'm going all the way over here to the left, my furthest most x value is -1, okay? And if I go all the way across this graph, all the way to here, my greatest x value is going to be 5. So if I were to describe the domain, again, we always go from left to right. If I describe the domain, I'm going to include, because this is a colored in circle, I'm going to include -1. And again, as I go all the way across the graph, I get all the way to 5. Well, at 5, I've got an open circle. So my domain would be from -1 to 5. That's all my x values in this graph. If I were to describe the range, I'm going to start from my minimum point and go all the way up. So in this graph, my lowest point is -3. So again, it is a colored in circle, so I'm going to include -3. And it is going to go all the way up to my highest point, which my highest point is 3. And again, that is also colored in, so that would also be a bracket there. So my domain, -1 to 5, my range, -3 all the way up to 3. Okay, let's take a look at the idea of finding some values here. Again, let me erase the previous slide here. I'm going to move on to finding values. The first one we're going to find is f of -1. So in this particular problem, let's just review. Remember what we've said, that f of x is technically the same thing as y. So really what I'm doing is I'm taking this -1 and I'm plugging it into the function, or seeing what my y value is going to be at that x value. So here, my x value of -1, here I am. Well, my y value is 1. So just looking at the graph, y would be 1. Let's look at another one. F of 2. Well, again, I go to my x value of 2. I go down here. Well, my y value would be, in this case, -3. And then let's do one more. If I did f of 0, again, I'm going to find my x value at 0. My x value is 0. I go up here, and that would be a +3. Okay? So again, if I had an equation, basically I'm just going to take this value and plug it in for x, and that's going to give me my functional output, or my y value. Okay? Let's go ahead and move on. Okay, so let's talk a little bit about the vertical line test and what that entails. The vertical line test for a function, we say a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects that graph at more than one point. So in general terms, basically if I've got a function, if I can draw a vertical line through any part of that graph and it passes through 2 or more points, I know it's not a function. Remember, each x can only have one y value. Okay, let's look at some examples here. If I'm looking at this first picture, again, it's kind of a sideways parabola here. Again, if I take and I draw anywhere on here a vertical line, which I can see here when I draw this vertical line, it passes through here and here, that tells me it's not a function. Okay, let's try another one. On this one, again, I draw my vertical line, draw a vertical line. Again, I take a look, and on this graph, it doesn't matter how many vertical lines I draw, and each one of them, it's only passing through at one place. So this would be considered a function. Let's do one more. One more again. If I draw my vertical lines through here. Again, even though there is a break in the action there, still my vertical lines are only passing through one point, so this also would be considered a function. So utilizing the vertical line test to determine if the graph is a function. Okay. Next concept, finding the zeros of a function. Remember, the zeros, or the solutions of a function, this is where the graph passes through the x-axis. In other words, it's where f of x equals 0. You know, if I'm looking at this graph, here's where the line crosses through, here's where the line crosses through. And on some of these, this particular one, we can identify what those are because it goes through at a point here. We could say, you know, this solution here would be 1, this solution 1, 2, 3 would be 4. So our zeros would be 1 and 4. Has two zeros, crosses the x-axis in 2 places. Well, let's talk about what we do if we're given the equation algebraically. How do we find the zeros? So here in this example, we've got f of x equals 3x squared plus x minus 10. Again, to find these zeros, we're going to put in 0 for y, or f of x. So I get 0 equals 3x squared plus x minus 10. Now, we learned in algebra class how to solve this type of equation. Again, multiple ways. We could use the quadratic formula. We could factor. Obviously, we could make a graph. All of those are options. I just happen to know in this one that this one does factor, so I'm going to use factoring. Again, remember 3x times x gives me 3x squared. I'm going to do a little guess and check, figure out what can I multiply to get negative 10 that pairs up with 3 and 1 to get me a 1. Well, I'm going to put in, I know a 5 goes here and a 2 goes here. Again, because the middle sign is plus, I want this to be a plus sign and this to be a minus sign. So 6x minus 5x gives me the 1x in the middle. If I then split that up, I'm going to set each of these equal to 0. And x plus 2 equal to 0. Now I can solve the two equations. I add 5 to both sides. So 3x equals 5 and divide by 3. So this one, x equals 5/3. On this one, a little bit easier, just subtract 2 from each side. So x is going to be negative 2. So here would be my two zeros of my function. Again, we're looking at 1 2/3 and negative 2. All right, let's look at a second example. Get another little algebraic. Now that we've done that one, you might want to pause the video, maybe just see if you can work through this one on your own before I go through it. Okay, I am going to take you through it again. We're going to set g of x equal to 0, the square root. Again, remember, when I'm solving a square root equation, easiest thing to do is to square both sides. If I square this side, I still get 0. Squaring the right side gets rid of the radical. Again, at this point, I can go ahead then and subtract 10 from each side. So I get negative 10 equals negative x squared. If I divide by negative 1, I end up getting x squared is equal to 10. And then I'm going to take the square root of both sides. Remember, when I take the square root, I do have to take both the plus and the minus of the square root. So in this case, it's plus square root of 10 and minus the square root of 10. So we're looking at just a little bit more than 3 point something. Again, that would be my two zeros there in this case. Okay. I do want to take you through one more. So again, another opportunity for you to pause the video, see if you can work through another problem where we're finding the zeros algebraically. I'm trying to give you just a few examples here that look a little bit different. Again, I'm going to put 0 in for h of t. Now I do have a fraction here. Probably the best thing to do in my mind is I'm going to go ahead and multiply by that denominator. So t plus 5 on both sides. Again, on the left, that still just gets me 0. 2t minus 3 because these are going to cancel each other out. Then I can go ahead and add 3 to both sides. So 3 is equal to 2t. I divide both sides then by 2. I find here that t is 3 over 2, or 1.5. Okay, so again, in this particular problem, just 1 0, 3 over 2. Okay, let's go ahead and erase that. And now let's kind of talk about our last objective here, and that is identifying increasing, decreasing, and constant intervals. That's basically describing the graph or describing the function. So the first scenario, increasing means if as x increases, then y is also increasing. So basically, when we're thinking about the graph, as x gets bigger or goes to the right, the y value is going up. So I'm going right, I'm going up. Basically, I'm going, up the hill. Decreasing. This is a situation where as x increases, so as we go from left to right, the f of x value goes down. So as I go left to right, my y value is going negatively or going down. Constant just indicates that as we go from left to right, the y value just stays the same. So we're just constantly going basically in a horizontal fashion across the graph. Okay? So hopefully that gives you a pretty good explanation if you're having trouble understanding that notation. Let's look at a couple of examples. It says use the graphs to describe the behavior of each function. So you'll notice on this particular curve we do have arrows, which indicates that it does continue this way infinitely, and it does continue up infinitely. So I've drawn my little stick figure guy here. Basically, as my stick figure guy goes to the right, he continues on this particular graph to go up. So we would consider that to be an increasing situation for the whole graph. So from the left side, which is negative infinity, so from negative infinity all the way to positive infinity, we are increasing on this one. So this would be considered an increasing graph. Okay, so for the interval negative infinity to positive infinity, it's increasing. Okay, let's look at another scenario where we've got a little bit of change in the graph. Okay, again, my little stick figure guy down here, again, we're starting over here at negative infinity, and we're going to go this direction until we get to the x value of negative 1. So for my first interval is from negative infinity, and that's going to go all the way to negative 1. Okay, and so for that interval, we are increasing. All right, now for the interval, once we get to negative 1, from negative 1 down to positive 1, now we have a decreasing interval. So from negative 1 all the way to the x value of positive 1, we are decreasing. And then once we get to 1, notice here we reached kind of a relative minimum point. That relative minimum point, now we start going back up. And so at this juncture from 1 to positive infinity, we're back to increasing. Okay, so you can kind of see here in our graph the end behavior. Increasing in the middle here we have a decreasing situation occurring. All right, I'll give you another example here, so you may be a good time for you to pause the video and just maybe attempt this last one. Again, on this last one, again, my little stick figure guy, from here until we get to this point is going up. So from negative infinity all the way to 0, in this case, we are increasing. Notice once he gets to 0, we go straight across until we get to the x value of 2. So in this interval from 0 to 2, we are constant because the y value is staying the same. And then from the x value of 2 to positive infinity, again, that's this interval, we have a decreasing situation. Okay? So again, increasing, constant, decreasing. Describing the graph based on what is going on in the different intervals of the graph.